Okay, so today's lecture, Google search. We'll dig about halfway through this, then we'll call it a day. So what we're going to cover, number one, how search works, number two, why it's needed, how it's evolved over time, and some basic search principles and techniques. And then towards the end, sometime tomorrow, we'll talk about advanced features that they implemented about 10 years ago for customization. So different search results for different users at different times based on their location, search history, stuff like that. And then Google Instant, which tries to complete queries for you. Okay, so search is something everyone uses, but most people don't really think about, right? The way it works, you try to describe what you want, and hopefully the machines deliver what you want. In terms of how search works, when the data is highly structured, it's very easy to search. If it's less structured, it becomes a lot more difficult. So I'm going to give you a very simple example. Phone books, right? Has anybody here ever seen a phone book? Who has seen a phone book? Raise your hand. Anybody? Been at your grandparents' house? You've seen it? Yeah, okay, so couple people have actually seen a phone book. The rest of you are like, what the hell is a phone book, Grandpa? Okay, so I'll explain it. A phone book, once upon a time, this is what people used. So image, phone, book. There's a big book like this, probably at least a couple inches thick for a reasonably sized city, with a long list of all the people that lived in there who were willing to have their phone numbers listed. Okay, that's what a phone book was. And it sounds crazy, but if you wanted to call somebody and you didn't know their number, that's how you looked up what their number was, because we didn't have the internet back in the 80s. So phone book entries are ordered in a couple ways, right? They're ordered by first, last name, then by first name, and then, if necessary, in many cases, by address. Okay, although that tends to be a little less formal. So what this means, if you know someone's last and first name, it's very easy to find their phone number, right? You flip open the book to the approximate page, right? For example, if last name starts with N, you know it will be around the middle of the book, right? At least in English-speaking zones, because that's the name distribution. Okay, so you know that. Then you can, flip a few pages around there, and scan the columns, and eventually find the entry, right? But if you only know someone's first name and address, you're so screwed, right? The data isn't indexed by those. Without the last name, you have to search the entire phone book, right? Literally every entry in it to find your target number. Okay, so we can understand this problem. When the data is structured, as long as you can search along that index, it's easy. So this works for things like database tables full of invoices, right? Searchable by invoice number. Okay, if the data is indexed by invoice number, it's very easy to search it by invoice number, right? The same thing as the phone book. You go to the approximate point in the middle of that table and then branch out from there. Likewise, you can create multiple copies of tables, of database tables, indexed on different fields for faster searching. For example, indexed by last name, first name, or customer ID, okay? But Creating additional fields, creating additional copies requires extra space for storage and also complicates the update process because more things need to happen synchronously, right? Anytime you change one of those copies, you have to dig through the other and change that as well. So it's a little bit of a headache, but it's manageable. You can do it. So this was for a long time. If any of you are old enough to remember, when you first started seeing online phone books, at first you had to search by last name. But later on, they started cross-indexing these tables in a lot of different ways. And now you can search for other, you can search on other indexes as well. For example, you can enter in an address and it can probably find the phone number of the person who lives there, person or persons. Okay, so key takeaway from all this, highly structured data is easy to search. Unstructured data is very difficult to search. For example, web pages. Pages don't have an inherent structure. They're a big sequence of HTML tags that describe what content is there, but there's not a single structured format for doing it. This is a huge problem. So how do you categorize this data? There simply is not a field that you can reasonably and usefully categorize a page on, right? So for example, you might categorize web pages by the name of the URL and the date that the page was created. But in most cases for search, that's not going to help you because that's not the way people are going to search. You're not going to search for, show me all the pages that are about shoes, right? Everything on shoes.com that was posted in 2011. It's just not how people search. It's not going to be useful. So let's talk about how web pages are built, then we'll go from there. So web pages contain text, objects, so things like images, buttons, scripts, and a variety of formatting instructions. So the text, right, could be presented in different fonts, different colors, styles, whatever, and with different orientations, so tilted in various ways or presented as hyperlinks to other pages. You can have objects included in the page, or they can be automatically integrated into the page when it's created on the server side. For example, like Google Ads, Google has one process that builds the page from the search results and another process that sprinkles the ads around those search results. And the objects themselves can have a variety of metadata. So things like labels, keywords associated with the ads, display priority, so where they're located on a page, and preferred size. So if they display in different sizes on large and small screens. Anyway, all these different web page elements, they can be combined in arbitrary ways, and there's no way that pages can be meaningfully ordered based on them. So this is a huge problem. If you have this gigantic collection of trillions of web pages like there are now, how do you go about coming up with a system that can actually deliver useful search results? All right, well, let's go for a little further on HTML. So markup languages. Once upon a time, we'll talk about this, way back when, if you were lucky enough to have a computer that actually had a digital display screen and not just a couple lights for on and off and program running. Okay, if you had one that had a digital display screen, you only had one font, right? Whatever it was, you lived with it. That meant that early web pages, do one word, early web pages didn't need to specify different fonts or styles, right? Like italics. Because everything would get displayed in the same format on the receiving machine anyway. But eventually, right, the internet started being accessed by machines that could handle multiple fonts, right? Like the early Apple machines were the first, perhaps, certainly the first widely used ones to do that. The old Macintosh ones. Okay, which meant now there was a reason to allow text to be displayed in different styles. Okay, thus markup languages, which what they try to do is basically mimic the human process of editing a document to show how it will be displayed. Okay, so the way it works, if you were to write a sentence, for example, the quick brown dog, or the quick brown fox jumped over the lazy dog. Okay, if you don't put any markups in there, it's going to be displayed as the default style. So say no markups, displayed in default style. Okay, but we could put in some markups, something like the, and I'll do an italics here for I for italics, and we'll close that out and do another one here. Okay, then it would display as the quick brown, oh, that should be an N, not an X, huh? That should be a fox. I don't know what happened there. Fox jumped over the lazy dog. Okay, that's the essential idea with markup languages. You have some tags that control how stuff is displayed. So for web pages, the core element is generally still text, but around text you do style elements and other content like images or videos to be displayed around it. Okay, that's why it's called a markup language, because you have your base text and the document is marked up with the additional formatting instructions. Okay, so example on the next slide here. So we have an online news article, and some of these tags, right, this is the HTML style. So HTML stands for hypertext markup language. Hypertext basically means there's text that can function as hyperlinks, so links to other pages or pages on other websites. So tags are going to specify some text as the main header, other text as subheaders. The article body is not enclosed in tags, so it uses the defaults. And individual words can be italicized or boldfaced by other tags around them. Okay, so if I take this, right, which I can copy all this. So here we have an article from McDonald's. So I'm going to go to an online HTML editor. Let's see what we find here. Oh, good, WYSIWYG. WYSIWYG, this thing, W-Y-S-I-W-Y-G. WYSIWYG stands for what you say, what you see is what you get. So it's going to display the way you want it to. All right, so I put the source code in over here. Okay, I'm going to get, I want to get rid of all this. Boom, it's all gone. I put in my code over here. Boom, this is what we have. So H1 tag here, that means a big header. The biggest header is the H1. H2 is a slightly smaller header. So McDonald's start selling donuts, strategy hopes to boost sales. Here I have a couple of boldface things. So donuts is in boldface, there it is. If I look through here, this P is for a paragraph tag. So at every new paragraph, it creates a little space between them. Here we have an italics for I, fresh, delicious donuts. And then A down at the bottom, that's a hyperlink, right? Well, it will be once I edit it. So I'll say href equals https www.mcdonalds.com. Okay, if I do this and I click on this, it can actually bring me to McDonald's. How about that? Okay. Anyway, so that's what we have here, right? So we can understand I have some raw text, and around that I put tags that mark it up and allow it to be displayed in different formats, or, again, show hyperlinks. Okay. Now, online search. So how does Google do it? And obviously, it's going to be a kind of complicated process. That's why Google makes the big money, is they were able to figure out this thing sooner and better than anybody else was able to. And that is a very valuable thing, and they make bags and bags of money doing it. So the core thing is text matching for things like the page titles or titles in the headers and also in plain text, and as image or other object metadata. So for example, if you have a retail site around selling shoes and you have a bunch of images around shoes, Google isn't going to look at those images and recognize that they're shoes. What you're going to do is you're going to put in some keywords that says, this is a shoe. And then when Google looks at the page, say, oh, yeah, okay, that's a picture of a shoe. We'll take your word for it. So text matching is the core technique. The second thing is accepting a certain amount of imperfection, right? Part of it is synonyms. For example, if you're just looking up the word bugs, well, an ordinary person looking up the term bugs is most likely going to be looking up insects. We can verify this. I can go straight to Google and do it. We'll go to Google and we look up bugs. And if I look up bugs, right, there it is, bugs, okay, by which they primarily mean insects, but we can expand that to mean creepy crawlies of, some non-insect types as well, okay? So there's that. However, we know that there are other meanings for bugs. For example, if I say computer bugs, well, then Google is not going to think bugs using computers or robot bugs. It's going to think defective software, right? Software bugs. So if I look up, I don't even need you. Why are you still there? If I look up software bugs, right, computer bugs, it's going to give me something different, right? Then, boom, software bugs right at the top. So flaws in the software. Okay, other things, misspellings. For example, if I type in the word BGUS, that could be bogus, right? I missed the U, or it could be I transposed the U and the G in bugs. Actually, last I checked this, it comes up with university, I believe in Kentucky, Bowling Green State University, BGSU. So let's see what we get today with that. BGSU. Aha, there it is. So BGUS, that's what I wanted to do. Did I mean bogus? So that's one option. Another one, we still have Bowling Green, right? We have some things, BGUS actually stands for some things, right? Some barrier gate openers. All right, so anyway, a bunch of different options. They're not really sure, right? Because it's about equally common to misspell bugs as it is to put in bogus, as it is to look for Bowling Green State University, as it is to look for these gate openers, whatever. A bunch of different possibilities there. Google's not 100% sure. Okay, so when you're doing search, ideally the search term that the user uses would, number one, correspond uniquely to a desired page, or at least give a good match to content. Once upon a time, this was largely true, right? When the internet was first started, the content that it had a fairly small number of repositories. The very first one was only like 4 computers. By 1973, I can see if I can find this. Somebody just posted this on Facebook. Internet Map 1973. Yeah, this is the very one. So this is kind of cool. If we zoom out, let's go boom, let's blow that up. This was everything on the internet in 1973. You could put it on one piece of paper, right? So there's Illinois, there's Utah, there's MIT. They got a cluster of things over there. There's Harvard, Aberdeen, London. They had a little thing, some West Coast stuff, USC and Stanford. Ooh, Hawaii had one. That's nice. Okay, so, but my point is, there wasn't that much. It wasn't that big of an operation, right? There are a few dozen, I don't know, it looks like about, I'm just eyeballing it, like maybe 80 or so different repositories. And on every one of those repositories, it's basically a file directory. So, excuse me, whatever you're looking for, you go to that location, you look up the particular research project you're interested in. If you have clearance to access the files, you can get in and you can access them, and that's how you do it. So there's not a whole lot of pages to search. It's pretty easy to find what you're looking for, right? You know that if you're involved with some project of, I don't know, Joe Blow over at Carnegie, who's like a top researcher there, you say, oh, let me look at Joe Blow's latest physics experiments. So you go to Joe Blow's entry, you go to physics, find that particular project from 1972, and there it is. It's not that hard to find stuff. But as the internet got bigger, especially as a wider variety of topics got included, right, it wasn't all just research stuff, then suddenly search becomes a big thing. It becomes a lot harder to find what you're looking for. So, other thing, right, there are a lot of common words that are found on a wide range of sites and pages, right? So any random word that I come up with is probably literally on millions of Google pages. So if I do the big one that I found, right, money is a good one, right? Money gives, let's see how many results I get for that. Billions, of course, but that gives 5.5 billion-ish. If I look up sports, last time I did that, I got like 20 billion, 15-ish, okay? All right, so obviously there are some things you get a lot of search results. There's no way anybody's searching through all that stuff in their lifetime. So what do we do? Well, one possibility is to narrow it down by adding extra terms. For example, if I search for shoe sale, but even shoe sale, that can come up with a bunch of different possibilities. So shoe sale, you know, I can find a bunch of ads for buying shoes, right? Here's some stuff, clearance, sale shoes. Uh, Basically, at this point in 2020, I'm going to get all retail stuff. But certainly in the early days, I could have gotten anything, right? I could have gotten shoe retailers. I could have gotten an article about a shoe sale. I could have gotten a page that has the word shoe and the word sale in completely different paragraphs that was not about a shoe sale at all. And this was a real problem for search engines, right? So they could find the pages that contain the words, but coming up with the understanding of what a shoe sale is, that was a whole much bigger problem. Okay, so Google uses context to try to decide which pages match which search terms well. So first of all, the way terms appear on a page is important. So for example, prominence. If a word appears on a page title, right, the big stuff that describes what the page is about, that's going to be far more important than ordinary text because the title should describe the purpose of the page. Other things, distance and sequence, right? So shoe sale with the words next to each other, sequential, and in the correct order is going to be considered a better match than these shoes are for sale, right? Where the words are in order, but they're a couple words separated, as opposed to I went to Target for their annual sale on socks. Ironically, I lost a shoe there. Sure, the words are there, but they're out of sequence and they're widely spaced. So shoe sale matches shoe sale really well. These other two, not so much. Other things, repetition. So if the term shoe sale appears in multiple places on a page, I become more confident that that's the primary purpose of this. Other things, like if there are a bunch of images on the page, so a typical retailer would not have just one image of a pair of shoes, right? Either it would be some page that shows a bunch of different shoe styles and has a bunch of images of different shoes, or it's a single page for a particular product and has a bunch of thumbnails of what this shoe would look like. Other things, if you include other terms in the search, right? So for example, if I use Bear Cubs versus Chicago Cubs, I'm going to get very different pages, right? Chicago Cubs is going to be all about baseball. Bear Cubs, well, probably about baby bears. Google also uses user location and history. So for example, if I do Cubs as a search in the Chicago area, I am probably overwhelmingly likely to get Chicago Cubs content. But suppose there's a big thing out in, I don't know, some zoo out on the West Coast, and they just got a couple of new polar bear cubs, and everybody's super excited about it. And maybe if you search out on the West Coast, if you run the word Cubs, you know, maybe that gets a lot more traction than Chicago Cubs. So you Google Cubs out there, you get stuff about the zoo. So it can all be very location specific as well. Okay. Now, on the user side, we understand, hopefully, the art of searching, but some people understand it better than others. My wife is a very smart person, but she does have some trouble coming up with good sets of search terms. But the real trick to it is to come up with the most unusual terms grouped together that still adequately describe what you're looking for. That way, you're going to remove a lot of garbage, irrelevant results from the search. So if you use less common, more precise words that closely match a topic, number one, you're going to get fewer matches, right? So instead of doing, say, just sports, you could do Chicago Cubs 2015 World Series, if that's what you're looking for. And then the truly relevant matches are going to be nearer to the top. Now, for example, if we do unemployment statistics, right? Suppose we're interested in unemployment statistics from the recession in the early 80s, some Rust Belt stuff in Rockford, Illinois, 1982. So if we Google unemployment statistics, just that, because that's what we want to look for, boom, we're going to get a lot of current stuff. We're going to get stuff from the Bureau of Labor Statistics that has all this, blah, blah, blah. We're going to get some stuff with historical data. And we're going to say, oh, that's not really what I'm looking for. Let's narrow it down a bit. So I'm going to Google unemployment statistics 1982. Oh, let's see what we get. Well, 1982, some bad stuff, right? It was a bad year for a lot of places. If I look around, I'm still not seeing much for Rockford, because although Rockford was hit hard by it, there were a couple of months where it had the highest unemployment in the country. Unfortunately for this search, it's still only a small part of the 1982 story, so not really showing up. But if I do the final incarnation of the search, unemployment statistics, Rockford, Illinois, 1982, then I'll get what I'm looking for, right? So boom, here we go. Here's an article from the Rockford Register-Star, their local newspaper. Here's something that was in the New York Times about how everything was all messed up. A variety of cities, again, in the Rust Belt troubles. So a lot of local stuff from the early 80s about Rockford. So by including that set of terms, I find what I'm looking for, right? So the more relevant search terms you can include, the more you can narrow it down to what are really good, relevant results. Okay. Now, why search is essential? Well, like I said, in the early days, the internet was pretty small and could basically operate like an oversized message board, right? If you only have 80 or so repositories of data, maybe a few hundred, there just aren't that many, right? You can go dig around in each one of those like a file folder. The content tended to be grouped into very clear categories, right? They were research projects in different domains like chemistry, physics, whatever, IT, computer networking, whatever they were doing. And within those folders, it would be associated by particular products, like Professor so-and-so was working on this. Because of that, it was sufficient to use these command-driven tools. So you'd type in some instructions in words, and you'd find what you were looking for that way. So the idea that there was some Windows type interface didn't really exist. If you're interested, you can look up this stuff, like Gopher was one of the applications for doing that. But as the internet got bigger, number one, you had more websites and more data, so anything you were trying to search through by hand became a much bigger headache, right? So these early command-driven tools, you had to locate the repository you were looking for and then dig around through that. Number two, you started having the problem where content was no longer easily or precisely categorized. It wasn't just a neat grouping of research projects, it was a variety of articles on a variety of topics, and it became really difficult to just categorize them on the basis of tags or, allocation to folders. Now, just to give you an idea of what was going on, by 2000, I mean, just looking at this, I don't know, it looks like about 25 million or so websites, within 10 or 15 years, it had gone up to 1 billion websites. It's bigger now, but I don't have the, let's see if they've updated this. Right now is about 1.8 billion. So there are more. Oh, look, they have updated it. I just grabbed that. All right, I'll grab that and use it on another day. I'll update the slides. Okay, so the numbers keep going up. So those are the little bumps we have, but then boom, keeps going bigger and bigger. Okay, other things, web page weight, right? This is the stuff that was on web pages. So in the early days, like 1995, still pretty early, pages were relatively small in terms of data because they were mostly text. So just a few kilobytes per page. And they say here the average number of objects, 2.3. Well, one of those is probably a link. Another one is maybe a button or an image, whatever. You just didn't have a lot of stuff on web pages. But, 20 years later, you're typically seeing over 100 objects per page, right? You want an example of how out of control some of this is, we go to Amazon.com. I'll keep that page. I'm going to use it. Okay. Boom. We go to Amazon.com, and there's lots of objects, right? So every one of these things here, these are all buttons. This is a text field, so there's like a couple dozen right there just without even scrolling down. Each of these things, right? Images, many images, many links embedded there. Literally dozens of things, more dozens, lots. Okay. And every one of these things down here, each one of these is a link. So there's like 50 of those. And look, there's more links down here. So here's like another 50 or so. So pages have a lot of content. They're a lot bigger than they used to be. So again, even if you were going to try to do it just on text, there's a lot of information that you're missing, right? All this contextual information, like the type of things on the web page, offer a lot of opportunity for better categorization of pages, better ranking. Okay, so search as a product. What do users want? Well, typical users, they want to get good search results quickly without thinking too hard. So to that end, your search engine should have, number one, a user-friendly interface, right? Something where you don't have to think a lot to use it. Number two, immediate response. The results should be delivered ideally in a fraction of a second. And number three, very relevant results. Hopefully, whatever the person is looking for is going to be right there on that first screen of results. So you don't have to go digging through multiple screens of search listings. And relevance is the strongest differentiating factor between search engines. So if we flash back to the great search engine wars of the 90s, this was the biggest thing. If you were a search engine that could deliver results that matched what people actually wanted to see, then people would keep coming back to use it, right? So irrelevant results, they're going to waste people's time. People are going to stop using that search engine. They say, this one's garbage. It just finds a bunch of stuff that I don't care about. But if you want to do a good job of assessing relevance, you're going to have to look at other things besides just matching terms to other terms, right? So, for example, what data would be helpful? So suppose you're looking for what time a movie is playing, right? So if you were looking for movie showings, right, that might be what you want to do. There could be a lot of different pages around the world showing movie showings, right? What, first of all, you would want to do is figure out what the location of that user is. And second, show that user movie listings from theaters local to that location. And the more precise you can have the user's location, the better off you're going to be. So for example, if you know somebody's in Chicago, they're, in like Lincoln Park, Chicago, they're right next to that Webster 14 theater, you might prioritize that. Or there was one up on Clark Street, the Century 8, I think it was. There was another one up there a little bit north, maybe just past Belmont or just before Belmont. Anyway, you would show the theaters that are very near to where that user is. And if a search engine can do that reliably, then people are going to say, hey, wow, this is good. I'm going to keep on using this engine. And once you have the people coming back, then you can start showing the ads along with it and make some money that way. Okay, so a variety of different kinds of data, but again, things like location are certainly a very good thing. So again, early internet search prior to the World Wide Web, so think, 1990 and earlier, internet search was a lot like searching for a file on a computer. So the organization stored their data in files, search tools help locate the files, and the matches, right, you could match the names or the type or the data, like when the file was created or updated. Those were all valid parameters to find what you were looking for. The difference was the data people were looking for was mostly research data. But as the World Wide Web started to dominate web usage, then you had a lot of more human interest type things, a lot of non-research topics. So search needed to match terms to text and content. So problem number one, figuring out how to do the matching, so which terms are going to be more important than others and how to group them together. And second, the idea of simple matching models are going to be very easily broken. For example, if you want your page to rank highly, you could make a junky page full of just popular search terms. And by doing that, it would automatically rank high in Google listings on a lot of different topics, because for everything, for example, if you found out that Google said, oh, if we see this word in a page header, we will give this, prominence. If you just used a header tag and put in every popular term you could think of, basically the entire dictionary and every famous person or place or thing in your web page, that would automatically rank really high in Google's naive search, right? Because anything that somebody would type in would show up with those words in the header. And so Google say, oh, that's what this page is about. It shows up in the header. So that was a big problem. Google solved that problem better and earlier than any of the competitors, and that, again, helped it cement its advantage. Okay. So we'll do one more slide, and then we'll call it a day. So this is the halfway point. This will be good. Okay, rise and decline of most search engines. So during the great search engine war of the 90s, there were a bunch of different companies that wanted to become the next Google, right? The idea was, I'll draw it out. Okay, so first, get a search model, show ads along with search results. Make money, okay? This was the basic process. Now, a lot of the companies that were on this, they stumbled in a couple of ways. So number one, I'll put this in red. Many failed because their search results were weak and irrelevant, right? They weren't what people are looking for. Another problem often happened. Search results cluttered with too many ads of little to no relevance. Okay, this was a common problem early on. So I'll give an example I'll give an example right now. So suppose I'm looking for the word eagles, right? And if I'm looking for eagles, that could mean a lot of different things. I could be looking for the bird. I could be looking for stuff about the football team. There was a band that was big in the 70s called the Eagles. There was a $10 gold coin called the Eagle in the United States. There were the little gold things that the Roman legions would carry around called eagles, called aquila, but same thing. It's just Latin for eagle. If I'm looking for any of those things, right, I could be looking to buy a pet eagle for some reason. Now, just the word eagle, people are going to think, oh yeah, that's probably not something you're looking for, right? That's not something that you can buy stuff around. So that you don't see any ads just for eagle. But if I look up Philadelphia Eagles, there's going to be ads, right? There's going to be some ads for gear, I would think. Maybe for this one there aren't. All right, let's see. I do this $10 eagle. There we go. I find some ads for that, some eBay things. So that's what the coin looked like, these guys. Anyway, so where was I going with all this? So a lot of the early search engines, they were just showing ads because the matches were kind of weak. So they might show, for somebody looking for birds, they might show ads for coins, or they might show ads for the Philadelphia Eagles. They just wanted to show anything, even if it was limited relevance, on the desperate hope that somebody would click on an ad and make them some money. But all that effort loading in ads, number one, made things work slower, drove customers away. So Google waited to start including the ads and got the whole system working pretty well before anyone else. That created user loyalty, which pretty much killed off the competition, right? Once people saw that, oh, we aren't getting much traffic to our search engine, so if we want to have anybody click on an ad, then we really have to pack the pages with ads. That just made it go downhill even faster. So afterwards, right, because Google had enough time and resources, they still kept on getting venture capital for this. They were able to keep their system going along, make it work better without weighing it down with a bunch of irrelevant ads. By the time the smoke cleared, they were the best operation standing. So this seems like a good point to break off because, again, we're halfway through the lecture. So we'll come back. We'll finish it up on Thursday. But let me ask, are there any questions about any of this stuff? Any stuff here that's not making sense yet? Or that you'd like a little bit of extra explanation about? How is everybody? What's happening? Nothing? Going once? Going twice. All right, gone. We'll see you all Thursday. Have a good day.